lights for me here. Please, thank you. Okay, so just listen to some of the concepts that I'm going to review, right? So we go back to page 39. The main idea here, guys, is this one right here. Morning. 39. Total possibilities, the total number of options that can occur would be, right, the first event and how many options you have there multiplied by the second event. Okay, so 2 meals, 3 drinks, there'd be 6 possibilities. Let's do a quick side note here. If I had 3 shirts, so they're all different colors, okay? That would be my first event. And I had 4 pair of pants. They were all different. And 3 different socks. How many different ways can I possibly get dressed? And how many different ways that are unique? Well, right, this would be event 1, event 2, event number 3. Okay, so I could even say, hey, you're rolling 3 dice. That would be, right, 6 options, 6 options, 6 options, right? So what would this be? Some mental math early in the morning. 3 times 4, 12, right? Times 3, 36. That's my sample space. That's like what is possible, right? I could do a tree diagram of this technically. It'd be a bit tedious, right? But your first would have 3 branches coming off, connected by 4, and then connected by 3. We're not going to do that in this course. If anything, I might make it a bonus on the test, right? But just understand this concept here. You multiply the options for each event because, right, the idea is I need all 3 of these to happen at the same time every single time, right? I need a shirt, I need a pair of pants, and I need a pair of socks, right? So 36 different outcomes there. So we have this here. This is written in general, right? Options 1 times options in the event 2, and ... means that would continue on for as many as are mentioned. Then we talked about 2 dice that are 4-sided, right? So we went options there, 4 times 4, 16. We made our outcome table, right? I'm going to ask you to do one of these on today's AC. You're going to have to fill out an outcome table and answer based on what you see there. Let's do a couple of examples, though, before we continue. Okay, so go to page 41 here. And I know you're tired. I know you're like, I just want to graduate. Some of you already got so many things going on, right? We just got to finish this unit and then home finance, stats, right? We're getting there. So just try to do your best to focus and pay attention, okay? Finish strong. So a game consists of tossing a coin. This is event number 1. And spinning a spinner. Okay, this is event 1, and event 2, right? So there's 2 events. How many possible outcomes are there? Anyone? Something times something, right? This is the coin. This is the spinner. Right? Coin, we should all know, has 2 sides, right? And the spinner, in this case, it's this one here. There are 5 sections there. So in this case, it's 2 times 5, 10 outcomes. If the game would consist of tossing a coin, spinning a spinner, and drawing a card from a deck of cards. 2 times 5 times 52, right? That's how many different outcomes you would have. So I hope that starts to make sense here. And we're going to see this visually. Make an outcome table and a tree diagram showing all the outcomes. And I'm telling you to use the first letter. So for G for green, and I made sure there aren't any doubles here, okay? No purple and something else that starts with a P. So a tree diagram, you choose which one you want to start with. You want to start with the spinner, you want to start with the coin, it doesn't matter. So let's start with a spinner. How many options? 1, 2, 3, 4, 5, right? And I'm just going to start with blue here. Blue, red, purple, yellow, green. I just started with blue and I went clockwise. Okay. That's your start. And now every single one of those branches has 2 options, right? Heads, tails, heads, tails. Right? HT, HT, HT. That's it. You're done. Actually, not quite. You're almost there. So you would say in this particular case, right, you would have spin a blue and land on heads. Then you'd have spin a blue and land on tails. Red, head, right? Red, tails. Purple, head. Purple, tail. Yellow, head. Yellow, tail. This is listing all the outcomes here. So you should see you have 10 outcomes. You should see that everything is connected. You don't need to make a tree diagram to know that there are 10. You could have just multiplied the outcomes, right? These are all different, unique results you play in the game. That's what you could get, right? Let's do an outcome table. This is a tree diagram. Tree diagram. And the outcome table here. And the answer is you choose how you want to do this, guys. It doesn't have to be like the exact same way I do it. So I would, for example, maybe go heads and tails. And then I'm going to use the same order that I have here. So blue, red, purple, yellow, green. Okay, these are my options. And then you just go right, BH, BT, RH, RT, right? And so I'm just going to do this first. Then I'm going to go over to this side and it's PT, YT, GT. Okay. And this is your outcome table. When there are only 2 events, 2 things happening, I prefer outcome table. If there are more than 2 events, you would have to stick with a tree diagram because it's just right. You would have a coin, spinner. Can you imagine doing a tree diagram for a card? For cards, 52. Every single one of these would have to have 52 lines going. We're not going to do that, right? It's just enough is enough, right? But again, you should see, right? There's 5 and 5, 10 outcomes. I want you to answer C and D because I set everything up for you now. You should be able to answer questions C and D, and also it says the odds, right? For C, the odds of that happening, the odds of that happening. Try to answer that before I go over it. Okay, take a minute or two. What is C? Okay. 1/5. Did you reduce it? That's why. Yeah, okay, got it. Okay, so the outcome of the spinner landing on purple, right? So then you go to your outcome table, and purple is right here. Okay, you have two options. It could be purple head or purple tail. So that'd be 2 out of 10, which is 1 out of 5. That'd be 0.2. That'd be 20%. That's your probability. Odds, take either one of these fractions, whichever one you prefer. We can take this one, so you go 2, and on the other side you go 10 minus 2, right? And that will give you 2 to 8. You can reduce this one, or you can use this fraction here and say it's 1 to 5 minus 1, which is 1 to 4. You see, everything is connected, right? Like you can reduce here and then get that, or you can just use this one and reduce that one. Everything is connected. Next, what's the probability of the outcome to either have blue or green? And in math, when you see the word or, it's plus. And is times. Okay? What are the odds of this happening later? Probability first. So blue, we have 2 options, and there are 2 greens, right? You go up here, 2 greens, and up here 2 blues, right? So do you want a highlighter? I don't know about that, right? 2 blues. I'm kind of done highlighting, right? Oh, that's okay. Green, right? Should use a green highlighter probably, but that's there. So we've got 2 and 2 there, right? 2 and 2 over 10. So that's 4 over 10, which is 2 goes into both of them. So that's 2 over 5 reduced, right? That's 40%. The odds of this happening, 2, right? And then 5 minus 2, so it'd be 2 to 3, or 4 to 6. If you got 4 to 6, you got full marks. Okay. From time to time, I will ask you to simplify, so that's why I'm showing you how to do that. So these types of questions where you base your answer on on your outcome table, you should be able to manage those. Okay. Yesterday I talked about sums greater than, right? When both of them are numbers, then you can add them up, of course. So then it's a little different. Let's go to 42. I want you to think a little bit here. Are you ready for this? This might require you being a little bit more awake than normal. Okay. I'm not going to lie to you, I'm pushing the limits a little bit on what you absolutely need to know on this one. So take it with a little bit of caution, right? So do you know the game Farco? You roll 6. Yeah, I know it sounds like something else, right? 6 6-sided dice. That's you roll every time and you count the 1s and the 5s. It's kind of like Yahtzee, similar. But how many possible outcomes would you have in this case? If you have 6 possible, this would be die 1, die 2, die 3. This is real world stuff, right? Die 6. You have 6 events happening here at the same time. You roll all 6. So we multiply them. I use dots to multiply. So we have 6 options. 6, right? Yikes. You think that's going to be a big number? You bet. You know powers. Do you remember your powers? Your secret superpowers, right? Yeah, this is 6 to the power of, how many do we have? 1, 2, 3, 4. Yes, 6 to the power of 6. So you can choose to go 6 times 6 times 6, or go 6, and I have this hat right here, or you have a y to the x or x to the y. They should all sit down, right? Calculator companies, and just like, let's all decide what we're going to use. Okay. And that's what your answer is. 46,656 outcomes. It's crazy, isn't it? It gets bigger than that. When it comes to license plates, phone numbers, all those things, you know they introduced 430 as our area code, right? Some of you have 430s already. Sorry, 431. Did I say 431? That's what I meant to say. That's because they ran out of numbers, right? So they had to start a new area code because they ran out of numbers. So they know, right? They know how many outcomes. Mr. D has a 4-digit PIN for his credit card. Okay. How many possible combinations are there? Show your work. Watch this. Digits are 0 to 9. 0 to 9. So you have actually 10 options. Does that make sense? Because you include 0 as one of your numbers. So if I have a 4-digit PIN, I think this is very important to know this kind of stuff, right? You have 10 options for your first number, 10 options for your second, and so forth. Hi there. No problem. No problem. Thanks. We're on page 42. It's coming. I waited for you. Okay. 10 times 10. So that's 10 to the power of 4. You should be able to do this without a calculator. Did you know that? If it's a 0, if it's a 10 base number, how many zeros will that number have? I'm not telling you. 4 zeros, you got it. $10,000 passwords possible. What's the probability that somebody will guess my password the very first time? How many chances are there? There's one correct password, right? 1 out of 10,000. Morning. We're on page 80. No, 42. I'm just kidding. 42. 1 divided by 10,000. That, let's multiply that by 100. That's 0.01% chance. So if somebody guesses your password, they steal your debit card, they will say you gave them the password, right? The bank literally will say there's the chances that that person guessed it are very low. So you must have had it in your wallet. You must have had the password maybe written in your wallet. Shouldn't do that, right? Maybe you told your friend, and your friend, right, like waited till you were like distracted. Hey, I'm gonna just withdraw $200, right, or whatever. Not a good friend, right? But anyways, so this is how you come up with that, right? You can tell your friends, like, there's no way, right? Like, you guessed it. You must have found out somehow. So don't share your password. According to a website Mr. D visited, the odds of being drafted to the NBA are 1 to 3,332. This is the internet. I don't know. Which is more likely to happen? Somebody guessing my password or somebody being drafted to the NBA. How would you do this? Can we turn this into a probability? So probability of NBA. This kind of crushed my dreams. No, I've been realistic for a long time. 1 over, I don't even play basketball, so why would they draft me, right? That's 3,333. 1 over 3,333. Let's find out what that would be as a percentage. 1 divided by 3,333. And multiply that by 100, okay? Because it's too small, you might as well. That's 0.03% chance. So there's a higher chance me being drafted into the NBA than someone guessing my password, right? It is more likely right, for someone, oh no, someone being drafted to the NBA, because it's slightly higher, right? Not by much, but that's right. Yeah. So I was just trying to come up with realistic scenarios here. That one not being one of them, but here Mr. D was not being careful during a purchase, and someone behind him saw that the first number was a 6. Right? What's the probability that a person can guess it now? It's still small, but let's go through this. This is my password, right? The first number is a 6. That person knows it, so there's only one chance for that option, right? This is taken, this is gone. So technically, that person only has to guess the 3 remaining digits, right? This is called the fundamental counting principle, by the way. You don't need to know that name, but that's so 10 to the power of. So that'd be 10 followed by 3 zeros. So what are the chances of somebody guessing it now? 1 over 1,000, because they don't need to worry about the first digit, right? It's a 6. Right? Don't get all excited. I just made that up, okay? I'm going to multiply that by 100. So that's 0.1% chance. So it has increased, not by much, but it has, right? Tenfold. So you're like, what's happening here? These are always outcomes, right? This is doing exactly what I've been teaching you all along, right? Like just multiply the outcomes in each event to come up with the total outcomes. Okay. So nothing new there. It's just maybe a little twist to it. I'm going to stop there. I'm just going to show you. I'm not going to answer anything, but here on page 43, I start talking passcodes for your phone, right? A lot of our phones have 6 or more digits these days, so I kind of do the same thing as your credit card or debit card pins, just more digits, right? So I'm going to leave it here for now and give you the AC because I want to prepare you for Tuesday's